Good evening and welcome to Dreamy Academy. Tonight we turn our gaze inward, not to the distant stars nor to the deep earth, but to a rhythm that began long before you and will continue, unwavering, for as long as you draw breath. As we begin, I'd love to know where you're watching from, your city, your country, perhaps even what the night sky looks like outside your window. If you enjoy these peaceful explorations of science, please take a moment to like the video and subscribe. It truly helps this little corner of quiet curiosity grow. To those already subscribed, thank you sincerely for being part of this slow and thoughtful adventure. And if you'd like to be gently reminded of our next journey, the notification bell awaits. Now settle into the quiet of your space. Close your eyes if you wish, and simply listen. Feel for a moment the steady, insistent thrum beneath your ribs. That beat, that quiet, powerful drum. It has been with you since before you had memories, before you had the language, before you were even aware of its presence. It began in the silent darkness of your earliest days, and it has not paused since. This rhythm, so intimately yours, is also a whisper from deep time, an echo of life's earliest stirrings, a universal pulse that unites all creatures with the circulatory system. The wonder of the heart is not merely its mechanical efficiency, though that alone is astonishing. It is its profound connection to the vast, patient story of life itself. It is a testament to evolution's ingenuity, a biological marvel that has been refined and perfected over hundreds of millions of years. To contemplate the heart is to contemplate life's tireless tenacity, its intricate beauty, and the fundamental forces that allow complex beings to exist. Tonight, we will drift through its silent chambers, trace the pathways of its ancient rivers, and listen to the science that sings within its tireless beat. The first beat, an ancient rhythm. Have you ever paused in the quietest part of the night to simply listen to the rhythm within you? Not the rush of thoughts, nor the distant sounds of the world, but the soft, steady cadence of your own heart. It's a familiar presence, so constant that we often forget its tireless devotion. Yet, within that ordinary miracle lies a story as vast as the oceans and as ancient as the first stirrings of life on earth. Tonight, let's begin by considering this most fundamental of rhythms, the heart's first beat, not just as a singular event in your own development, but as an echo of an impulse that has driven life for eons. This gentle thrum, this pulse that marks the passage of every moment, is more than just a muscle contracting. It is a living clock, a pump, a messenger, and an architect of flow, all contained within a modest, fist-sized organ. Over the course of an average human lifetime, your heart will beat approximately 2.5 to 3 billion times. It will move enough blood to fill 3 supertankers, and it will do so without conscious command, without a moment's rest from your earliest days in the womb until your final breath. This isn't just a biological process. It is a profound testament to the elegance and resilience of life itself, a wonder that rewards our patient contemplation. To truly appreciate the heart, we must first understand its fundamental purpose. Imagine a vast, intricate city, teeming with billions of inhabitants, each a single cell within your body. These cells, like tiny citizens, need constant supplies of nutrients and oxygen to thrive, and they produce waste products that must be carried away. How does a city of such staggering scale, where every citizen is isolated from the external world, manage this colossal task? It builds a transport system a network of roads and rivers constantly moving resources to where they are needed and waste away from where it accumulates. Your circulatory system is precisely this, an elaborate, closed network of vessels stretching for roughly 100,000 kilometers, enough to circle the Earth 2.5 times, all powered by that single tireless pump. This need for internal transport is not unique to complex creatures like us. It is an ancient problem, one that evolution began solving hundreds of millions of years ago. Picture a simple multicellular organism, perhaps a flatworm, lying in the primordial ocean. Its cells are close enough to the surface to absorb nutrients directly from the water and release waste. But as life grew larger, thicker, more complex, direct diffusion became insufficient. Cells deep within the organism would starve or poison themselves. The solution? A dedicated internal river system. And for a river to flow, it needs a current. It needs a pump. The earliest hearts were not the sophisticated 4-chambered marvels we possess. They were far simpler, often just pulsating tubes, segments of blood vessels that rhythmically contracted to push fluid along. In creatures like earthworms, you find multiple aortic arches, simple contractile vessels that serve as auxiliary hearts, pushing blood through their segmented bodies. This is the very essence of a heart, a structure designed to generate pressure, to create flow, to overcome the resistance of a closed system, ensuring that every distant cell receives its due. It is a principle born of necessity, refined by the slow, patient hand of evolution across countless generations. Consider the evolutionary journey. From those simple pulsating tubes, the heart gradually became more centralized, more powerful, and more complex. In fish, we see a single-circuit system. Blood is pumped from a 2-chambered heart to the gills for oxygenation, then directly to the rest of the body, before returning to the heart. It's efficient for aquatic life where the density of water helps support the vessels and the pressure drop across the gills is manageable. But when life ventured onto land, gravity became a new challenge, and the demands for oxygen soared. Amphibians and reptiles developed 3-chambered hearts, allowing for a partial separation of oxygenated and deoxygenated blood. This was a crucial innovation. Instead of sending all blood through the lungs and then directly to the body, some blood could be routed to the lungs for oxygen, then returned to the heart to be repumped at higher pressure to the rest of the body. This double circulation system, though still allowing for some mixing of oxygen-rich and oxygen-poor blood, was a significant leap in efficiency, enabling more active, terrestrial lifestyles. Imagine the immense pressure of natural selection, silently sculpting this organ over millions of years, favouring any slight improvement in oxygen delivery, any small gain in endurance or metabolic rate. Each tiny genetic variation that led to a more effective pump was a whisper of survival, amplified across countless generations. The pinnacle of this evolutionary journey, for mammals and birds, is the 4-chambered heart. Here, the separation of oxygenated and deoxygenated blood is complete. 2 separate pumps work in exquisite synchrony. One circuit, the pulmonary circulation, sends deoxygenated blood to the lungs to pick up oxygen and release carbon dioxide. The other, the systemic circulation, then takes that freshly oxygenated blood and propels it with tremendous force to every tissue and organ in the body. This absolute separation allows for maximum efficiency, delivering oxygen at high pressure and speed, fueling the high metabolic rates required for sustained warmth, flight, or the complex thought processes that define us. What makes this constant, tireless beating possible? It is not merely a mechanical pump responding to external signals. The heart possesses a remarkable property known as intrinsic rhythmicity. Buried within its walls are specialized cells that generate their own electrical impulses, setting the pace for the entire organ. It is as if the heart has its own internal conductor, an orchestra leader that initiates each beat, even in isolation from the brain. The brain and nervous system can modulate this rhythm, speeding it up during excitement or slowing it during rest, but they do not initiate it. The heart wants to beat. It possesses an inherent autonomous drive, a fundamental biological imperative to maintain the flow of life. This intrinsic rhythm is itself a marvel of biochemical and biophysical elegance. It arises from the precise interplay of ions, charged atoms like sodium, potassium, and calcium, moving across cell membranes, creating tiny electrical currents that sweep through the heart muscle. Each impulse is a wave of depolarization, a rapid shift in electrical potential that triggers the muscle cells to contract. And because these cells are electrically connected in a continuous network, like an intricate wiring diagram, one cell's impulse quickly propagates to its neighbors, resulting in the coordinated, powerful contraction we recognize as a heartbeat. It is a self-sustaining electrical symphony, playing out billions of times over a lifetime, a testament to the sophistication woven into the very fabric of our cells. There's a particular comfort in understanding that this most vital organ, the very engine of your existence, operates on principles refined over geological timescales. The heart is not just a pump, it is a living artifact of deep time, carrying within its structure and function the accumulated wisdom of millions of years of evolutionary experimentation. It speaks of the persistent drive of life to adapt, to survive, to thrive. Looking back across those eons, we see not chaos, but a relentless patient sculpting, leading to the elegant solution that now beats within each of us. The universe, it seems, has a tendency toward creating such intricate, self-sustaining marvels. This knowledge changes how we perceive that familiar beat. It is no longer just a sound, but a direct connection to an unbroken chain of life stretching back to the earliest organisms that needed to move resources internally. It is a symbol of resilience, of an unending commitment to the flow of energy and matter that defines a living system. The heart, in its tireless devotion, reminds us of the profound continuity of life, a constant rhythm in an ever-changing world. It is the core of our physical being, yes, but also a quiet, pulsing testament to the enduring wonder of biological design. So we've seen how the heart, from its earliest, simplest forms, evolved into the remarkably efficient four-chambered organ that powers our lives, a master of internal transport and an autonomous generator of rhythm. But this raises a quieter, more intimate question. How does this tireless engine, this self-starting pump, actually generate its power at the most fundamental level? What are the specific cellular mechanisms, the tiny electrical sparks and muscular contractions that translate this ancient rhythm into the palpable force of a heartbeat? That question leads us into the microscopic world of the heart's own cells, where the very chemistry of life orchestrates each magnificent beat. Chapter 2. The Spark and the Contraction, a Symphony of Cells. In our previous journey, we marvelled at the heart's ancient rhythm, its tireless evolution from a simple pulsating tube to the magnificent four-chambered engine that powers our every breath, our every thought. We touched upon its intrinsic desire to beat, its self-sustaining electrical symphony. But as we concluded, a deeper question lingered, a whisper from the very core of this living marvel. How precisely does this tireless engine generate its power at the fundamental cellular level? What are these specific electrical sparks and muscular contractions that orchestrate the dance of life within us. Today we embark on an even more intimate exploration, venturing beyond the macroscopic into the microscopic, into the silent, bustling cities of cells that comprise the heart. Prepare to witness a ballet of ions, a symphony of proteins, and an astonishing display of coordinated energy. Close your eyes, if you wish, and simply listen. Imagine shrinking, becoming infinitesimally small until you can drift within the very walls of the heart. What you encounter are not just undifferentiated tissues, but highly specialized, resilient individual cells, the true architects of its power, the cardiomyocytes. These are the heart muscle cells, and they are unlike any other cells in your body. They are branched, like tiny intricate river deltas, connecting to their neighbors in a complex three-dimensional web. These connections are not haphazard. They are exquisitely designed junctions called intercalated discs, which act as both structural anchors and electrical bridges. Within these discs lie specialized channels known as gap junctions, serving as direct conduits for electrical signals, allowing ions to flow freely from one cell to the next, almost as if they were a single colossal cell. This unique arrangement is critical, for it enables the heart to function as a syncytium, a unified, synchronized whole, ensuring that every beat is a perfectly coordinated contraction, not a chaotic flutter. Now let us peer closer at the very essence of that electrical spark. Recall that the heart possesses its own intrinsic rhythm, primarily governed by a small cluster of specialized cells in the right atrium, called the sinoatrial node, often called the heart's natural pacemaker. But what does it mean for a cell to generate an electrical impulse? It means a carefully choreographed dance of charged particles, ions, moving across the cell membrane. Imagine the membrane of a single cardiomyocyte as a delicate semi-permeable boundary, separating the inner world of the cell from its external environment. Across this membrane there's a delicate balance of electrical charge, maintained by ion pumps that work tirelessly to keep specific ions, sodium Na+, potassium K+, and calcium Ca2+, at different concentrations inside and outside the cell. This creates an electrical potential, a readiness, like a coiled spring. The spark begins when this resting potential is disturbed, reaching a threshold. For a cardiomyocyte, this is typically initiated by an electrical signal arriving from a neighboring cell via those gap junctions. Suddenly, voltage-gated sodium channels in the cell membrane snap open. Sodium ions, which are far more concentrated outside the cell, rush inward, flooding the cell with positive charge. This rapid influx causes a dramatic shift in the cell's electrical potential, a sharp upward spike we call depolarization. This is the initial rapid phase of the action potential, the very first flicker of the spark. But here, the cardiac action potential reveals its unique genius, distinguishing itself from the simpler, faster spikes of nerve or skeletal muscle cells. Immediately after that initial sodium rush, a crucial event unfolds. Calcium channels open, allowing calcium ions to slowly stream into the cell. Simultaneously, some potassium channels also open, allowing potassium to flow out. This delicate balance of inward calcium current and outward potassium current creates a sustained plateau phase in the action potential. This plateau is profoundly important. It prolongs the electrical signal, ensuring that the heart muscle has enough time to fully contract before it can be stimulated again. This built-in refractory period prevents the heart from going into tetany, a sustained, uncontrolled contraction, which would be catastrophic. Imagine your heart locking up, unable to relax and refill with blood. The plateau phase is the heart's elegant, built-in safety mechanism, ensuring a rhythmic pump-fill-pump cycle. Finally, as the calcium channels slowly close, more potassium channels open, allowing a strong outward flow of potassium ions. This outflow of positive charge restores the cell's negative resting potential, a process known as repolarization. The cell resets, ready for the next beat, the next spark. This entire sequence, depolarization, plateau, repolarization, is the cardiac action potential, a precise electrical wave that ripples across billions of cells, coordinating the heart's powerful contraction. It is an electrical dance, a wave of charge, meticulously timed and executed. So we have witnessed the spark. But how does this electrical signal translate into the powerful muscular contractions that pump blood through your body? This is where the magic of excitation-contraction coupling truly shines, a process where an electrical event is transformed into a mechanical force. That influx of calcium ions during the plateau phase is the crucial messenger. As calcium enters the cardiomyocyte from outside, it triggers an even larger release of calcium from an internal storage compartment within the cell, the sarcoplasmic reticulum. Imagine a tiny, intricate network of internal reservoirs, ready to unleash a flood. This surge of intracellular calcium is the signal that ignites contraction. Calcium ions then bind to a regulatory protein called troponin, which is associated with the thin filaments, actin, within the muscle cell. In its resting state, troponin, along with another protein called tropomyosin, blocks the binding sites on actin, preventing the muscle from contracting. But when calcium binds to troponin, it causes a conformational change, a subtle shift that pulls tropomyosin away, exposing those binding sites. This is the cue for the thick filaments, composed of the protein myosin. Myosin heads, like tiny articulated arms, reach out and bind to the newly exposed sites on actin. Powered by the energy currency of the cell, adenosine triphosphate, ATP, these myosin heads then pivot, pulling the actin filaments past the myosin filaments. This is the essence of the sliding filament theory. The filaments themselves don't shorten, but they slide past each other, causing the entire muscle cell to shorten and generate force. It's a microscopic ratcheting motion, repeated billions of times in perfect synchronicity. With each pivot, a molecule of ATP is hydrolyzed, releasing energy, and then a new ATP molecule binds, allowing the myosin head to detach and reset for the next stroke. It is a tireless, intricate dance of attachment, pivot, detachment and reattachment, all fueled by ATP. And where does this vital ATP come from? How does the heart, which never rests, generate the colossal energy required for its incessant work? This brings us to the mitochondria, the undisputed powerhouses of the cell. Cardiomyocytes are packed with mitochondria far more densely than most other cell types, often occupying up to 30–40% of the cell's volume. These tiny bean-shaped organelles are the heart's internal furnaces, tirelessly converting fuel into ATP through the process of aerobic respiration. The heart is remarkably adaptable in its fuel choices. While many cells rely primarily on glucose, the heart is a master of metabolic flexibility. Its preferred fuel source is often fatty acids, which provide a rich, sustained supply of energy. However, it can also readily utilize glucose lactate, especially during the periods of high demand or exercise, and even amino acids. This metabolic versatility ensures that, under various physiological conditions, the heart always has a reliable source of ATP to power its continuous electrical activity and mechanical contraction. It is a testament to evolution's foresight, designing an engine that can run on multiple fuels, guaranteeing its unyielding function. So, we return to the grand overview. We have journeyed into the individual cardiomyocyte, witnessed the electrical spark of the action potential, traced the path of calcium as it triggers the muscular contraction, and understood the tireless energy generation within the mitochondria. But let us not lose sight of the profound coordination that makes this all possible. Those gap junctions, those direct electrical bridges between cells, ensure that the wave of depolarization sweeps across the entire heart muscle almost instantaneously. When one cell fires, its neighbors follow suit, and the neighbors after that, creating a synchronized wave of contraction that begins in the atria, pushing blood into the ventricles, and then sweeps through the ventricles, propelling blood out to the lungs and the rest of the body. It is a symphony of cells, billions strong, each performing its precise role, yet all acting as one. The individual cardiomyocyte, with its unique electrical properties, its calcium-triggered contractions, and its abundant mitochondria, is a micro-marvel. But the true astonishment lies in their collective intelligence, their ability to self-organize into a coherent, rhythmic, and incredibly resilient organ. This is not merely a pump, it is a living clock, a dynamic engine, a testament to millions of years of evolutionary refinement, all unfolding within the quiet confines of your chest. As we conclude this segment, take a moment to feel your own pulse. Each beat, each thrum against your fingertips is the culmination of this intricate cellular ballet. It is the silent, powerful drumbeat of life powered by these microscopic sparks and contractions, a continuous miracle of biological engineering. In our next session, we will explore how this powerful engine is integrated into the vast network of the circulatory system, carrying the breath of life to every corner of your being. Until then, carry with you this sense of wonder, this profound appreciation for the invisible, tireless work happening within you. We have journeyed together, you and I, into the very heart of the heart, delving into its intricate cellular ballet, its self-sustaining electrical rhythm, and the profound wisdom encoded within its tireless muscle. We have witnessed the microscopic marvels of cardiomyocytes, the swift dance of ions, and the elegant mechanics of contraction, all culminating in that powerful rhythmic beat. It is a symphony indeed, a micro-marvel of collective intelligence, beating autonomously in the quiet darkness within us. But how, you might wonder, does this magnificent engine, this solitary, powerful drum, connect to the vast, sprawling landscape of the body it serves? How does its ceaseless work translate into life for every single cell, every distant outpost, every whispering nerve ending, every flexing muscle fibre? The heart, in all its self-contained glory, is but the magnificent pump, the central sun from which the very river of life flows, nourishing and sustaining. And it is this river, this ancient, intricate network, that we shall now explore together. Close your eyes, if you wish, and simply listen, simply feel. Can you sense the subtle hum within you, the gentle thrum of circulation that is happening right now in every part of your being? It is an internal ocean, a vast, complex system of pathways that reaches further than any map, more intricately than any city's plumbing. This is our circulatory system, a closed loop, an endless journey for the vital fluid we call blood, propelled by the very heart we have come to understand. Imagine, if you will, a vast interconnected city, alive with activity. The heart is its central power station, its mighty reservoir. From this reservoir, a network of grand, robust thoroughfares our arteries emerge. These are the superhighways of our internal landscape, designed for speed and pressure, carrying the freshly oxygenated, nutrient-rich blood away from the heart to every corner of your body. Feel your pulse for a moment. That rhythmic throb against your fingertips is the powerful surge of blood as your heart ejects it into these resilient, elastic vessels. Their walls are thick and muscular, capable of withstanding the immense pressure generated by each beat, expanding and recoiling to help maintain that forward momentum. They branch and narrow like rivers dividing into tributaries, becoming progressively smaller. Arterioles. The critical control points, the toll booths that regulate blood flow into specific tissues and organs, directing the current precisely where it is needed most. But the true magic, the very essence of life's continuous exchange, happens not in these grand arteries, but in the most delicate, the most intimate of vessels, the capillaries. These are the silent, unseen threads woven into the very fabric of every tissue, every cell. They are extraordinarily thin, often just wide enough for a single red blood cell to squeeze through, forming an astonishingly vast network that, if laid end to end, would stretch for tens of thousands of miles within each of us. Think of them as the finely embroidered lace of life, the delicate interface where true communion occurs. Here, in these microscopic capillaries, the vibrant oxygen-rich blood, brimming with nutrients, hormones, and warmth, slows to a gentle, contemplative pace. The walls, only a single cell thick, are permeable, allowing for a profound, silent conversation between the blood and the surrounding tissue cells. Oxygen, like a precious gift, diffuses out from the red blood cells, slipping across the thin capillary membrane to nourish the waiting cells. Nutrients, glucose, amino acids, fatty acids, follow suit, fueling the endless cellular processes. At the same time, the cells, in their metabolic work, release their waste products, carbon dioxide, lactic acid, urea. These unwanted guests diffuse into the capillaries, ready to be carried away. It is a constant dynamic exchange, a testament to the elegant efficiency of life happening in every single moment in every single part of your body. This is where the delivery and the collection occur, where the life-sustaining essence is exchanged, where the silent vital breath of every cell is taken. Having fulfilled its sacred mission of delivery and collection, the blood, now depleted of oxygen and enriched with waste, begins its journey home. The capillaries gently coalesce, like tiny streams merging into larger rivulets, forming venules. These in turn combine to create the larger veins, the return routes to the heart. Unlike the high-pressure arteries, the veins are lower-pressure vessels. Their walls are thinner and less muscular, but they possess a remarkable feature, a series of one-way valves. Imagine these as tiny, delicate gates, ensuring that the blood flows only in one direction, ever forward, ever upward, against the pull of gravity, back towards the heart. The gentle contraction of surrounding skeletal muscles as we move also aids this venous return, squeezing the veins and pushing the blood along. It is a collaborative effort, a testament to the body's integrated design, ensuring that the river of life always finds its way back to its source. This vast, intricate network, this continuous loop, is actually composed of two distinct yet perfectly integrated circuits, both originating from and returning to our four-chambered heart. We speak of the more systemic circulation and the more pulmonary circulation. The more systemic circulation is the grand journey, the expansive outward voyage. It begins in the heart's powerful left ventricle, which propels the bright red oxygenated blood into the aorta, the body's largest artery. From there, this vital current surges through the arterial network, reaching every cell, every tissue, every organ, from the crown of your head to the tips of your toes. Here in the capillaries, the life-giving exchange we just discussed takes place. The blood, now deoxygenated and laden with metabolic waste, collects in the venules and veins, eventually returning to the heart's right atrium. This is the heart's role as the central hub for the entire body, delivering and retrieving continuously. But before this deoxygenated blood can embark on another systemic journey, it must be reoxygenated. And this is where the pulmonary circulation comes into play, a vital shorter detour, a journey to the very breath of life. From the right atrium, the deoxygenated blood flows into the right ventricle, which then pumps it into the pulmonary artery, leading directly to the lungs. Here, in the vast, delicate network of capillaries surrounding the tiny air sacs, alveoli of your lungs, another profound exchange occurs. Carbon dioxide, the waste gas, diffuses out of the blood and into the air sacs, ready to be exhaled. Simultaneously, the fresh oxygen you breathe in diffuses from the air sacs into the blood, binding to the hemoglobin within your red blood cells. The blood, now vibrant with oxygen once more, flows from the lungs back to the heart's left atrium, completing the pulmonary loop. From the left atrium, it moves into the left ventricle, poised to begin its systemic journey anew. Can you perceive the elegant dance, the seamless transition between these two vital circuits? The heart, in its magnificent design, acts as two pumps in one, each size dedicated to its unique task, yet perfectly synchronized. The right side receives deoxygenated blood from the body and sends it to the lungs for oxygenation. The left side receives oxygenated blood from the lungs and propels it with immense force to the rest of the body. It is a continuous, balanced flow, ensuring that every beat serves a dual purpose, maintaining the delicate equilibrium of life. And what of the blood itself? This liquid medium of life that flows within these remarkable vessels. It is far more than just a carrier. Blood is a complex living tissue, a dynamic river that transports not only oxygen and nutrients, but also hormones, those subtle chemical messengers that orchestrate our body's functions. Immune cells, our vigilant internal defenders against invaders, and of course the waste products destined for removal by the kidneys and lungs. It regulates our body temperature, stabilizes our pH, and ensures that every corner of our internal world remains in harmonious balance. It is the very essence of our interconnectedness, a silent testament to the constant renewal and adaptability of life. This vast, intricate system, this network of rivers and streams, is not a static entity. It is dynamically regulated, constantly adjusting to the body's ever-changing needs. When you run, your heart beats faster, stronger, and your arterioles dilate in your muscles, directing more blood flow to meet the increased demand for oxygen and nutrients. When you rest, the flow shifts, prioritizing digestion or repair. This exquisite control, this fine-tuning is orchestrated by a complex interplay of the nervous system and various hormones, all working in concert to maintain optimal cell blood pressure. The force exerted by the blood against the walls of these vessels. Too high and it stresses the delicate system, too low and tissues are starved. The body's wisdom, its inherent intelligence, continuously adjusts, ensuring the perfect pressure, the perfect flow for every moment. So we return to our initial question and find our answer. The heart, this powerful self-sustaining engine, integrates into the vast network of the circulatory system as its indefatigable core, its central sun, its ceaseless pump. It is the driving force behind the river of life, pushing, pulling, and guiding the vital current through the intricate tapestry of arteries, capillaries, and veins. Without the heart, the river would cease to flow. Without the vessels, the river would have no path. And without the blood, the river would carry no life. Together, they form a profound and ancient partnership, a testament to billions of years of evolution, a living, flowing miracle that whispers of the primordial ocean from which we all arose. We carry this ancient river within us, this testament to life's enduring power, flowing, always flowing in the silent darkness of our own being. Take a moment now to simply feel that flow. It is the very pulse of life itself. We have journeyed together, haven't we, through the heart's ancient beat, its cellular symphony, and the vast, intricate rivers of its circulatory domain. We have seen how this tireless pump propels the very essence of life through arteries, capillaries, and veins, ensuring that every distant cell receives its vital sustenance and every waste product is swiftly carried away. We have marvelled at the blood itself, a complex elixir dynamically regulated to maintain optimal pressure and flow. But now, as we pause at the threshold of this new exploration, a profound question naturally arises. How is this magnificent orchestration achieved? Who are the unseen maestros, the silent conductors, guiding this internal river system, ensuring its perfect rhythm and adaptive flow moment by moment, breath by breath? Today we turn our gaze inward, not just to the heart's intrinsic pulse, but to the sophisticated, often unconscious systems that govern its every nuance, tuning it exquisitely to the ever-changing demands of our existence. We are entering the realm of the heart's silent conductors, the intricate networks of nerves and hormones that hold the reins of this vital force, transforming a simple pump into a responsive living instrument. Imagine, if you will, the heart as a skilled dancer, capable of moving independently, yes, but also exquisitely attuned to the music of its environment. This music, this subtle guidance, comes primarily from what we call the autonomic nervous system, or ANS. It is the invisible hand, the quiet whisper that ensures your heart rate rises when you climb a flight of stairs, or gently slows as you drift into sleep. It operates largely beneath the radar of your conscious thought, a testament to the body's innate wisdom, its profound capacity for self-regulation. The ANS, in its elegant simplicity, comprises two primary branches, two opposing yet complementary forces, much like the ebb and flow of a tide. We have the sympathetic nervous system, often characterized as the body's accelerator pedal, and the parasympathetic nervous system, its gentle brake. Consider the sympathetic nervous system as the body's alarm system, its call to action, its readiness for the challenges of the world. When you experience stress, excitement, or a sudden need for energy, perhaps you're faced with an unexpected task or you hear a sudden loud noise, this system springs into action. It releases powerful chemical messengers, primarily norepinephrine, directly onto the heart and blood vessels, and also stimulates the adrenal glands to flood the bloodstream with epinephrine, commonly known as adrenaline. What happens then? You feel it, don't you? Your heart quickens its pace, beating with a stronger, more forceful rhythm. This is the sympathetic system increasing both your heart rate or chronotropy and the strength of its contractions or inotropy. Simultaneously, it constricts many of your blood vessels, particularly those leading to organs less critical in an immediate emergency, like your digestive system. This redirects blood flow to your skeletal muscles, your brain, your lungs, preparing you to fight or flee. It is the heart transforming into a racehorse, muscles taut, ready to bolt, optimizing every drop of oxygen and nutrient for immediate peak performance. Then there is the parasympathetic nervous system, the soothing counterpoint, the gentle hand that guides you back to tranquility. It is the rest and digest system, the quiet whisper that encourages recuperation and calm. Its primary messenger is acetylcholine, delivered to the heart mostly via the vagus nerve, a long, wandering nerve that descends from the brainstem. When the parasympathetic system is dominant, your heart rate slows, its contractions become less forceful, and many of your blood vessels subtly relax, promoting a more even, gentle flow. It is the heart returning to its natural steady rhythm, like a calm river flowing peacefully through its banks, allowing for deep rest, digestion, and renewal. These two systems are not always in an either-or state. Rather, they are in a constant dynamic interplay, a delicate dance of push and pull. Your body is always seeking equilibrium, a state of homeostasis, and the ANS is the master choreographer of this intricate ballet. It ensures that your heart is always precisely tuned, whether you're running a marathon or simply meditating, always adapting to the internal and external landscapes of your life. Beyond the immediate neural commands, a fascinating array of chemical messengers, hormones, also play a crucial role in shaping the heart's performance and regulating blood pressure. These hormones are released by various glands and travel through the bloodstream, acting as long-distance signals, amplifying or fine-tuning the messages sent by the nervous system. We touched upon were epinephrine and norepinephrine from the adrenal glands, which reinforce the sympathetic system's accelerating effects, acting like a body-wide emergency broadcast system. But there are other vital players. Consider the renin-angiotensin-aldosterone system, RAS, a complex multi-organ feedback loop that acts as a vigilant guardian of your blood volume and pressure. When your kidneys detect a drop in blood pressure or blood flow, they release an enzyme called renin. Renin then triggers a cascade, ultimately leading to the production of some angiotensin II, a remarkably potent substance. Angiotensin II does several things. It's a powerful vasoconstrictor, tightening blood vessels throughout the body, thereby immediately raising blood pressure. It also stimulates the release of aldosterone from the adrenal glands, a hormone that instructs your kidneys to retain sodium and consequently water. By increasing the amount of fluid in your bloodstream, aldosterone effectively boosts your blood volume and in turn your blood pressure. It's a sophisticated, multi-layered mechanism, a testament to the body's dedication to maintaining its vital internal environment. And then there's antidiuretic hormone, ADH, also known as vasopressin, released from your pituitary gland in response to dehydration or low blood volume. ADH encourages your kidneys to reabsorb more water, preventing its loss through urine, and also acts as a mild vasoconstrictor, helping to conserve fluid and maintain pressure. On the flip side, when blood volume and pressure are too high, the heart itself plays a role. Stretched cells in your atria release atrial natriuretic peptide, ANP, a hormone that encourages your kidneys to excrete more sodium and water, thus reducing blood volume and promoting vasodilation. ANP acts as a kind of internal pressure release valve, preventing the system from becoming overloaded. But how does the body know when to activate these systems, when to accelerate or apply the brakes, when to release this hormone or that? It relies on a network of incredibly sensitive sensors, the heart's internal sentinels, constantly monitoring the vital signs of your internal world. These are the baroreceptors and chemoreceptors. Baroreceptors are specialized pressure sensors located in key arterial locations, particularly in the arch of your aorta and in the carotid sinuses, which are bulb-like enlargements in your carotid arteries in the neck. These tiny but mighty sensors are like miniature pressure gauges, constantly measuring the stretch of your arterial walls, which directly reflects your blood pressure. If blood pressure rises, the baroreceptors send signals to your brainstem, prompting the parasympathetic system to slow the heart and dilate vessels, bringing pressure back down. If pressure drops, they trigger the sympathetic system to increase heart rate and constrict vessels, raising pressure. It's a remarkably swift and precise feedback loop, ensuring that your brain always receives a steady, optimal supply of blood regardless of your position or activity. Chemoreceptors, on the other hand, are the body's atmospheric monitors. Located in the carotid bodies and aortic bodies, these sensors are exquisitely sensitive to the chemical composition of your blood, specifically to levels of oxygen, carbon dioxide, and pH. If oxygen levels drop or carbon dioxide levels rise, indicating a need for more breathing, these chemoreceptors send urgent signals to the brain. This not only increases your breathing rate but also influences your heart rate and blood pressure, ensuring optimal gas exchange and efficient transport of oxygen to your tissues. They are the guardians of your internal atmosphere, ensuring its perfect balance. All of these intricate regulatory mechanisms converge to determine two critical metrics: cardiac output, CO, and blood pressure, BP. Cardiac output is simply the amount of blood your heart pumps per minute, a direct product of your heart rate, HR. How many times it beats per minute, and stroke volume, SV, the amount of blood ejected with each beat. So, CO x HR x SV. Your heart rate, as we've seen, is primarily regulated by the delicate interplay of the sympathetic and parasympathetic nervous systems, along with various hormones. But stroke volume, the sheer power of each individual beat, is a more complex interplay of three factors. 1. Preload. This refers to the volume of blood filling the heart's ventricles at the end of diastole, just before contraction. It's essentially the stretch on the cardiac muscle fibers. The more blood that returns to the heart, venous return, the greater the stretch, and thanks to a principle known as the Frank-Starling mechanism, the harder the heart will contract to eject that blood. Think of it like stretching a rubber band. The more you stretch it, the more forcefully it recoils. 2. Contractility. This is the inherent strength of the heart muscle's contraction, independent of its initial stretch. It's influenced by the sympathetic nervous system, circulating hormones like epinephrine, and the availability of calcium ions within the heart muscle cells. Increased contractility means the heart can eject more blood with each beat, even at the same preload. 3. Afterload. This is the resistance the heart must overcome to eject blood into the arteries. It's primarily determined by the stiffness of your arteries and the degree of vasoconstriction in your systemic circulation, what we call systemic vascular resistance, SVR. If afterload is high, e.g. due to narrowed, stiff arteries, the heart has to work harder to push blood out, potentially reducing stroke volume. These three factors, preload, contractility, and afterload, are constantly adjusted by the nervous and endocrine systems to ensure that your stroke volume, and therefore your cardiac output, perfectly matches your body's moment-to-moment demands. Finally, we arrive at blood pressure, BP, the vital force that drives blood through your vast circulatory network. Blood pressure is fundamentally determined by two key factors: your cardiac output, CO, and your systemic vascular resistance, SVR. So, BP equals COX, SVR. Every mechanism we have discussed today, the sympathetic and parasympathetic nerves, the cascade of hormones, the vigilant baroreceptors and chemoreceptors, and the intricate regulation of preload, contractility, and afterload, all work in concert, a symphony of regulation, to maintain this critical pressure within a remarkably narrow optimal range. It is a testament to the body's profound intelligence, its unwavering commitment to life. As we conclude this exploration, we are left with a deeper appreciation for the heart not merely as a pump, but as a dynamically regulated marvel, a responsive instrument constantly adjusting, sensing, and responding to the myriad cues from within and without. This intricate dance of regulation ensures that every cell receives what it needs, every moment of every day, sustaining the very fabric of your being. But what happens when this delicate balance is disturbed? What are the implications when these silent conductors falter, when the symphony of regulation goes awry? What are the challenges and triumphs associated with maintaining the heart's health in a world that often tests its resilience? These are the profound questions that will guide our journey as we delve into the heart's vulnerabilities and its enduring strength in our next chapter. We have journeyed together, haven't we, through the intricate landscapes of the heart, from its ancient pulsating origin to the sophisticated symphony of its cells, the vast rivers of its circulation, and the silent, masterful conductors that regulate its every beat. We've marvelled at the exquisite balance, the ceaseless dance of electrical impulses and chemical messengers, all conspiring to maintain the delicate equilibrium of life within us. It is a system of profound elegance, a testament to billions of years of refinement. But what happens, you might ask, when this grand design encounters discord? What occurs when the rhythm stumbles, when the silent conductors falter, even for a moment, or when the meticulous balance we've so carefully observed begins to waver? Today, we turn our gaze to these disturbances, not to instill fear, but to deepen our understanding, to appreciate the heart's vulnerability as much as its strength, and to recognize the subtle whispers that sometimes precede a louder cry for attention. For in understanding the disruptions, we gain an even profounder appreciation for the marvel of its normal function and perhaps a clearer path toward its preservation. Imagine, if you will, our internal river system, the circulatory network, designed for a specific pressure, a gentle yet firm flow that nourishes every cell. Now envision that pressure steadily, almost imperceptibly rising. This silent ascent, this gradual tightening of the riverbanks, is what we call hypertension or high blood pressure. It is often a quiet thief, stealing away the heart's ease without a single alarm bell in its early stages. You might feel nothing at all, even as the delicate inner lining of your arteries, the endothelium, begins to experience the relentless strain. Remember how blood pressure is a product of cardiac output, how much blood the heart pumps, and systemic vascular resistance, the tightness of the vessels? In hypertension, often both play a role, but the increase in resistance is a common culprit. The tiny arterioles, those critical gateways to the capillary beds, constrict more than they should, or lose their elasticity, forcing the heart to work harder to push blood through. Think of a garden hose, its nozzle slowly tightening even as the pump tries to maintain the same flow. The pressure inside builds. Over years, this sustained effort takes its toll. The heart, specifically the left ventricle, begins to thicken, to hypertrophy in an attempt to overcome the increased afterload. It becomes a stronger muscle, yes, but also a stiffer one, less compliant, less efficient in its relaxation and filling. It's like a finely tuned instrument, forced to play at too high a volume for too long, its strings stretching, its wood straining. And the arteries themselves, those resilient conduits, harden and narrow, becoming less elastic, more prone to damage. This relentless pressure sets the stage for a cascade of other challenges, a domino effect within our intricate internal city. One of the most insidious of these challenges is atherosclerosis. If hypertension is the increased pressure in our river system, atherosclerosis is the gradual silting and narrowing of the riverbeds themselves. It begins, we believe, with subtle damage to that delicate endothelial lining of our arteries, perhaps from high blood pressure, perhaps from elevated cholesterol, from smoking, or from chronic inflammation. This damage is like a tiny scratch on the smooth inner wall. Into these microscopic abrasions, certain substances, particularly low-density lipoproteins, LDL, often called bad cholesterol, begin to infiltrate and accumulate. Our immune system, ever vigilant, sends its clean-up cells, the macrophages, to the site. But in an attempt to clear the debris, these macrophages become engorged with cholesterol, transforming into foam cells, which contribute to the formation of a fatty streak. This is the earliest visible lesion, a soft, yellowish smudge on the arterial wall. Over time, this fatty streak evolves. Smooth muscle cells migrate to the site, laying down fibrous tissue, calcium deposits accumulate, and a complex structure, known as an atherosclerotic plaque, begins to form. This plaque is not merely a passive blockage, it is a living, growing entity, pushing into the lumen of the artery, narrowing its passage. Imagine those ancient rivers, once wide and free-flowing, now slowly choked by sediment and debris. Their currents becoming turbulent, their capacity diminished. The danger of these plaques extends beyond mere narrowing. They can be unstable, prone to rupture. If the fibrous cap covering a plaque tears, the inner fatty core is exposed to the bloodstream. This exposure is perceived by the body as an injury, triggering the coagulation cascade, the body's natural clotting mechanism. Platelets rush to the scene, forming a clot or thrombus rapidly. And this, you see, is where the most acute dramas unfold. When atherosclerosis affects the coronary arteries, those vital vessels that supply blood to the heart muscle itself, we call it coronary artery disease, CAD. These arteries, remember, are like the heart's own internal irrigation system, ensuring it receives the oxygen and nutrients it tirelessly demands. If a plaque in one of these coronary arteries grows large enough to significantly restrict blood flow, or if a plaque ruptures and a thrombus completely blocks the artery, the segment of heart muscle downstream from that blockage is starved of oxygen. This state of oxygen deprivation is called ischemia. If the ischemia is prolonged and severe, the heart muscle cells, the cardiomyocytes we spoke of in Chapter 2, begin to die. This irreversible damage, the death of heart tissue due to lack of blood supply, is what we term a myocardial infarction, or a heart attack. It is a profound, sudden disruption to the heart's capacity, a section of its powerful wall silenced, unable to contract, unable to contribute to the rhythmic pumping. The consequences depend on the size and location of the damaged area, but the heart, in its profound wisdom, will attempt to heal, replacing dead muscle with scar tissue, which, while structurally sound, does not contract or conduct electrical impulses. And what then, if the heart, over time, loses its ability to pump effectively, unable to meet the body's demands for oxygenated blood? This is the insidious progression towards heart failure. It is not that the heart stops beating entirely, and rather it fails in its function as an efficient pump. This can happen for several reasons. Perhaps years of uncontrolled hypertension have stiffened the ventricle, diastolic heart failure, where the heart struggles to fill, or a massive heart attack has weakened its muscle, preventing it from contracting with sufficient force, systolic heart failure, where the heart struggles to eject blood. Think of our heart as that quiet, powerful drum beating its steady rhythm. In heart failure, the drum still beats, but perhaps its skin has lost its tension, or its frame has become rigid. It struggles to create the powerful vibrations needed to resonate throughout the body. The symptoms, though often subtle at first, become increasingly profound. Shortness of breath as fluid backs up into the lungs, swelling in the legs and abdomen. Profound fatigue as vital organs receive insufficient blood flow. The body, in its desperate attempt to compensate, activates many of the regulatory systems we discussed in Chapter 4, the sympathetic nervous system, the HAS. But these compensatory mechanisms, meant for short-term crises, become detrimental in the long run, further straining an already weakened heart. Beyond these structural and functional failures, the heart's exquisite electrical system, its internal clock and conducting pathways, can also falter. These are the arrhythmias, or irregular heartbeats. Remember the precise choreography of the cardiac action potential, the seamless spread of excitation, the perfect timing of contraction and relaxation. An arrhythmia is a disruption to this choreography. It can be a beat that comes too early, too late, or a rhythm that is too fast, too slow, or utterly chaotic. Consider atrial fibrillation, one of the most common arrhythmias. Instead of a single unified electrical impulse originating from the SA node and spreading smoothly across the atria, there are myriad disorganized electrical impulses, causing the atrial muscle to quiver rather than contract effectively. The ventricles then receive erratic signals, leading to an irregular and often rapid heartbeat. It's like the orchestra leader has lost control, and the violins are playing a different tune from the cellos, resulting in a cacophony rather than a harmonious symphony. While some arrhythmias are benign, others can significantly impair the heart's pumping efficiency, leading to symptoms like palpitations, dizziness, or even increasing the risk of stroke due to blood pooling and clotting in the quivering atria. What becomes clear as we explore these disturbances is their profound interconnectedness. Hypertension often precedes atherosclerosis, which in turn can lead to coronary artery disease and myocardial infarction, culminating in heart failure. Each condition, each disruption casts a shadow upon the others, creating a complex web of challenges for the heart. And underlying many of these conditions are the choices we make, the invisible threads of our daily lives, our diets, our activity levels, our management of stress, our exposure to toxins. These are not merely external factors, they are woven into the very fabric of our physiology, influencing the delicate balance of our internal systems. Yet even in the face of such vulnerabilities, the heart remains an organ of astonishing resilience, often adapting, often compensating, striving always to maintain life. Our understanding of these disturbances is not an end point, but a beginning, a call to deeper awareness, to proactive care, and to the continuous quest for knowledge that empowers us to protect this most vital of our internal organs. We learn not only what can go wrong, but also how remarkably well the heart performs, day in and day out, against incredible odds, a testament to the enduring power of life itself. As we conclude this chapter, I invite you to reflect on the journey we've undertaken. From the primordial pulse to the intricate dance of cells, from the vast circulatory rivers to the silent conductors of regulation, and now to the moments when that magnificent rhythm falters. Each step has revealed another layer of wonder, another facet of this extraordinary organ. In the next chapter, we will turn our attention to the fascinating world of diagnostics and interventions, exploring how we listen to the heart's whispers and cries, and how we strive to restore its harmony. For now, let us simply hold this complex tapestry of health and illness, marveling at the heart's profound story. We have journeyed together, haven't we, through the heart's intricate landscape, from its ancient rhythms to its modern vulnerabilities. We have seen how its harmony can falter, how its silent symphony can be disrupted by the dissonant notes of disease. Now, my dear friends, we turn our gaze towards how we, as guardians of this vital organ, begin to truly listen to its whispers and cries, and how we strive with all the wisdom and ingenuity we can muster to restore its profound, life-sustaining harmony. How do we begin to understand the troubles within this tireless muscle, this living clock that ticks away within us? We begin often with the most ancient and intimate of tools, the ear, amplified by the simple, elegant stethoscope. Imagine, if you will, placing this instrument upon the chest, a direct conduit to the heart's inner chambers. What do we hear? We hear its fundamental rhythm, the steady lub-dub, the sound of valves closing in perfect synchronization. But beyond this foundational beat, we listen for anomalies, for the subtle deviations that tell a story. Perhaps a murmur, a gentle whooshing sound that might indicate a valve not closing completely or not opening wide enough, disrupting the smooth flow of blood. Or perhaps an extra beat, a subtle hitch in the rhythm, a premature contraction that momentarily disrupts the steady cadence. These are the heart's first whispers, its quiet pleas for attention, and learning to discern them is an art as much as a science, honed by countless hours of patient listening. Beyond the immediate sounds, we seek deeper insights into the heart's electrical soul. This is where the electrocardiogram, or ECG, often called EKG, becomes our invaluable map. Imagine the heart's electrical impulses, those tiny sparks that initiate each beat, leaving a signature, a unique waveform. The ECG captures this electrical journey, translating it into a series of peaks and valleys on a graph. We see the P wave, the gentle rise as the atria depolarize and contract, pushing blood into the ventricles. Then comes the sharp, powerful QRS complex, the mighty surge as the ventricles depolarize and contract, propelling blood out to the body and lungs. Finally, the T wave, the tranquil return as the ventricles repolarize and relax, preparing for the next beat. Each segment, each interval, tells a story about the timing and health of the heart's electrical conduction system. An irregular rhythm, a prolonged interval, an elevated or depressed segment. These are the heart's more urgent cries, revealing conditions like arrhythmias, or even the telltale signs of ischemia, where parts of the heart muscle are starved of oxygen, signaling a potential heart attack. It is a language of waves, a silent conversation transcribed for us to interpret. But the heart is more than just electrical impulses. It is a magnificent, intricate structure, a pump of muscle and valves. To visualize this architecture, to see the heart in motion, we turn to echocardiography, or echo. This remarkable technology uses sound waves beyond the range of human hearing to create moving images of the heart. Think of it as an internal sonar, allowing us to peer directly into the beating chambers. We can see the thickness of its walls, the size of its ventricles, the strength of its contractions, often quantified as an ejection fraction. The percentage of blood pumped out with each beat. We can watch the delicate dance of the heart valves, ensuring they open fully and close completely, preventing leakage. An echo can reveal a thickened, struggling ventricle from years of hypertension, a damaged valve that allows blood to regurgitate, or even areas of heart muscle that are no longer moving effectively after a heart attack. It allows us to witness the heart's physical form, its structural integrity, and its functional prowess, providing a vivid, real-time portrait of its inner workings. Sometimes, to truly understand the heart's suffering, we must go deeper, literally, into its arterial network. This is the realm of cardiac catheterization and angiography. Imagine a tiny flexible tube, a catheter, delicately guided through a blood vessel, typically in the wrist or groin, all the way to the heart and the openings of the coronary arteries. Once in place, a special dye is injected, and X-ray images are taken, revealing the intricate network of blood vessels that nourish the heart itself. This is where we can directly visualize blockages caused by atherosclerosis, those narrowed or completely obstructed pathways that starve the heart muscle of vital blood flow. It's an invasive procedure, yes, but it provides unparalleled clarity, allowing us to pinpoint the precise location and severity of coronary artery disease, transforming a suspected problem into a tangible visual reality. Alongside these imaging techniques, we also rely on the silent messengers within our blood. Simple blood tests can reveal a wealth of information. Elevated levels of specific enzymes or proteins like troponin are the unmistakable cries of a heart muscle that has been damaged, a clear indicator of a myocardial infarction. Other markers such as BNP, B-type natriuretic peptide, can signal the stretching and stress on the heart muscle characteristic of heart failure. And of course, cholesterol panels and blood glucose levels provide crucial insights into the underlying risk factors that contribute to cardiovascular disease. We might also ask the heart to perform under pressure, to reveal its secrets when pushed to its limits. This is the purpose of stress testing, where we either ask you to walk on a treadmill or cycle, or we use medications to mimic the effects of exercise, while continuously monitoring your ECG and blood pressure. The goal is to see how your heart and its blood supply respond to increased demand. If a blockage is present, symptoms like chest pain or changes on the ECG might only appear when the heart is working harder, revealing an insufficiency that is not apparent at rest. It's like asking a bridge to bear a heavy load to test its strength. The heart too will show its vulnerabilities when challenged. With these diagnostic tools, we gather the heart's story, deciphering its whispers and understanding its cries. But our journey does not end with understanding. It extends to action, to the profound effort of restoring harmony. How do we strive to bring balance back to this magnificent, struggling organ? We begin always with the foundations of life itself. Lifestyle modifications. This is not merely advice, it is a profound recognition of our interconnectedness with our environment and our choices. A diet rich in whole foods, vibrant with fruits and vegetables, low in processed sugars and unhealthy fats, is a powerful medicine. Regular physical activity, even moderate, consistent movement strengthens the heart muscle, improves circulation, and helps maintain a healthy weight. The cessation of smoking, that insidious destroyer of arterial health, is perhaps the single most impactful choice one can make. And the cultivation of calm through practices like mindfulness or simply finding moments of quiet reflection helps to soothe the nervous system, taming the stress response that can strain the heart. These are the first, most fundamental steps in retuning the heart's rhythm, often preventing the need for more drastic interventions. When lifestyle changes alone are not enough, or when disease has progressed, we turn to the intricate pharmacy of medications. Each class of GER is designed to address a specific imbalance, to gently nudge the heart and circulatory system back towards equilibrium. For hypertension, we might use CUP beta blockers to slow the heart rate and reduce the force of contraction, or AE inhibitors to relax blood vessels and lower blood volume. Diuretics help the body shed excess fluid, easing the burden on a failing heart. For high cholesterol, statin work to reduce its production, slowing the progression of atherosclerosis. Antiarrhythmics are prescribed to stabilize irregular heartbeats, while anticoagulants or antiplatelets thin the blood, reducing the risk of clot formation that can lead to heart attacks or strokes. It is a delicate dance of chemistry carefully tailored to each individual, aiming to support the heart's function and protect it from further harm. Yet, sometimes the harmony is too broken, the blockages too severe, for lifestyle and medication alone to suffice. This is when we consider more direct, often invasive, interventions. For coronary artery disease, where arteries are dangerously narrowed, we might perform angioplasty with stenting, percutaneous coronary intervention, or PCI. Imagine that catheter again, guided to the site of the blockage. A tiny balloon is inflated, pressing the plaque against the arterial walls, widening the pathway. Often, a small mesh tube, a stent, is then deployed to hold the artery open, a tiny scaffold ensuring the river of life can flow freely once more. For more extensive or complex blockages, coronary artery bypass graft, CABG surgery, may be necessary. This is a profound intervention where new pathways are created, bypassing the diseased sections of the coronary arteries. Surgeons meticulously graft healthy blood vessels, often taken from the leg or chest, to connect the aorta to the coronary artery beyond the blockage, literally creating a new, open road for blood to reach the heart muscle. It is an act of engineering, a rerouting of life's essential currents. For those whose electrical system is profoundly disrupted, leading to dangerously slow or erratic rhythms, pacemakers come to the rescue. These small implanted devices continuously monitor the heart's rhythm and deliver precisely timed electrical impulses to ensure a steady, life-sustaining beat. For individuals at risk of sudden cardiac arrest due to life-threatening fast arrhythmias and implantable cardioverter defibrillator ICD, can be a true guardian angel, capable of detecting such an event and delivering a life-saving electrical shock to reset the heart's rhythm. When heart valves falter, either failing to open properly, stenosis, or failing to close completely, regurgitation, they can be repaired or, if necessary, replaced with prosthetic valves, either mechanical or biological. And in the most severe cases of heart failure, where the heart is irrevocably damaged and all other treatments have failed, the ultimate intervention is considered: heart transplantation, offering a new chance at life with a donor heart. It is a testament to human empathy and medical marvel, profound exchange of life. We stand at the intersection of deep scientific understanding and profound human compassion. Each diagnostic tool, each therapeutic intervention represents countless hours of research, discovery, and dedicated care. We listen with our stethoscopes, we visualize with our echoes, we map with our ECGs, and we intervene with our medicines and our surgical skills, all in service of that tireless, wondrous organ within us. And so we complete our journey through the fundamental science of the heart, from its ancient origins to its modern challenges, and the remarkable ways we strive to protect and restore it. We have explored its anatomy, its physiology, its vulnerabilities, and the marvels of medical intervention. But remember, this is not just a lecture. It is an invitation for you to carry this knowledge, this sense of wonder, into your own understanding of life. For the heart, in all its complexity, remains a profound mystery, a symbol of life itself, beating within each of us. I thank you for joining me on this exploration, for lending your curiosity and your presence to this deep dive into the heart of everything. And so we arrive at this quiet moment, at the close of our shared voyage. We have journeyed together, haven't we, through the intricate landscapes of the human heart, from its earliest whispers in the primordial deep to the complex symphony it orchestrates within each of us today. We have traced its evolutionary arc, peered into its microscopic wonders, navigated the vast river systems it powers, and marvelled at the exquisite precision of its regulation. We have confronted its vulnerabilities and celebrated its remarkable resilience, exploring the tools that safeguard its rhythm and the interventions that mend its delicate structure. Now, as the echoes of our exploration begin to soften, we find ourselves standing on a precipice of understanding, looking back at the profound vista we have traversed. What remains is not merely a collection of facts, but a deeper, more resonant appreciation for this tireless organ, this quiet, powerful drum at the centre of our being. Remember, if you will, those nascent stirrings in the earliest forms of life, the simple rhythmic pulsations that once propelled nutrients through a nascent organism. We saw how, over eons, this fundamental beat evolved, refining itself, layering complexity upon complexity, until it became the sophisticated, four-chambered pump we carry within us. It is a story written in the very fabric of our being, a testament to deep time and the relentless ingenuity of life itself. Your heart, my heart, is a living fossil, carrying the echoes of ancient oceans and the wisdom of countless generations. It is a biological archive, a continuous link to the very dawn of multicellular existence, beating with the rhythm that predates memory, predates consciousness, yet underpins them both. Think back to the silent darkness within, to the microscopic realm where this grand narrative truly unfolds. We spoke of the cardiomyocytes, those specialized cells, each a tiny marvel, yet collectively forming a powerful synchronized force. Can you still envision the dance of ions across their membranes, the precise choreography of sodium, potassium and calcium creating those vital electrical sparks? These action potentials, these tiny surges of energy, are the silent language of the heart dictating its every contraction. And then, the flood of calcium, the binding to troponin, the graceful slide of actin and myosin filaments, drawing the muscle fibers together in a powerful coordinated embrace. This is excitation-contraction coupling, a process of breathtaking elegance and efficiency, consuming vast stores of ATP, the very currency of life, to generate the mechanical force that sustains us. It is a ballet of molecules, a continuous, relentless performance happening billions of times over a lifetime, all without conscious command, all in the service of life. From this cellular level, we expanded our view to encompass the grand architecture of the circulatory system, the heart's magnificent kingdom. We followed the crimson current as it surged from the left ventricle into the mighty aorta, branching into arteries that narrow into arterioles, finally diffusing into the vast, intricate lacework of the capillaries. It is here, in these microscopic vessels, that the true magic of exchange occurs, where oxygen and nutrients are lovingly delivered to every cell, and metabolic waste products are gently collected for removal. Then the blood, now deoxygenated, begins its journey home, gathering in venules, converging into veins, flowing back to the right atrium, a silent, persistent river always seeking its source, always completing its circuit. This internal river system spanning tens of thousands of miles within your own body is a testament to engineering on a scale that dwarfs any human creation. It is a closed loop, perfectly balanced, perpetually in motion, ensuring that no cell, no tissue, no organ is ever truly alone, always connected, always nourished. And how is this vast, intricate system so meticulously managed? We delved into the heart's sophisticated regulatory mechanisms, a complex interplay of internal and external forces. The autonomic nervous system, that unseen conductor, orchestrating the tempo, the sympathetic branch, like an invigorating surge, accelerating the beat when demand calls, the parasympathetic branch, a calming hand slowing it when rest is needed. We explored the subtle whispers of hormones like epinephrine, urging the heart to greater efforts, or the intricate dance of the renin-angiotensin-aldosterone system, antidiuretic hormone and atrial natriuretic peptide, all meticulously calibrating blood volume and pressure, ensuring optimal performance. And the internal sensors, the baroreceptors in your carotid arteries and aortic arch, vigilantly monitoring pressure, the chemoreceptors, acutely sensitive to the subtle shifts in oxygen, carbon dioxide, and pH, all sending vital feedback, allowing your body to adapt, to respond, to maintain that delicate homeostatic balance. It is a living clock, a self-regulating machine of astonishing precision, constantly fine-tuning its output to meet the ever-changing demands of your life. Yet, for all its power and precision, we also learned of the heart's vulnerabilities. We understood how the relentless march of time, coupled with lifestyle choices, can lead to conditions like hypertension, silently straining its walls, or atherosclerosis, gradually narrowing the vital coronary arteries that feed the heart itself. We saw the devastating consequences of a myocardial infarction, a heart attack, where a critical supply line is severed. We grasped the insidious progression of heart failure, where the pump, once so robust, begins to falter, struggling to meet the body's needs. And the arrhythmias, those erratic rhythms that disrupt the heart's perfect cadence, reminding us of its delicate electrical balance. These conditions are not isolated events, but often interconnected chapters in a larger story of cardiovascular health, underscoring the profound impact of our daily choices on this most vital organ. But our journey did not end with challenges. It extended to the remarkable ingenuity of human intervention. We explored the diagnostic tools that allow us to listen to its whispers, to see its structure, to read its electrical language, the humble stethoscope, the revealing ECG, the vivid echocardiogram, the invasive yet invaluable cardiac catheterization, the insights gleaned from blood tests and the stress tests that push its limits. And then, the interventions, from the foundational importance of lifestyle modifications and targeted medications, to the precise artistry of angioplasty and stenting, the life-saving rerouting of bypass surgery, the rhythmic support of pacemakers, the vigilant guardianship of ICDs, the restorative power of valve repair and replacement, and finally, the profound gift of heart transplantation. These are not merely medical procedures. They are testaments to human compassion, scientific dedication, and an unyielding commitment to preserving the precious gift of life. So here we are at the conclusion of our formal study, but truly at the beginning of a deeper, more personal understanding. What we have explored together is more than just anatomy and physiology. It is the story of life itself, etched in every beat. It is a story of endurance, of adaptation, of interconnectedness. Your heart is not merely a pump, it is the central engine of your experience, intimately linked to your thoughts, your emotions, your very capacity to engage with the world. It is a testament to billions of years of evolution, a masterpiece of biological engineering and a constant, unwavering presence within you. As you move forward, I invite you to carry this newfound perspective with you. Let the knowledge we have shared deepen your appreciation for the silent, tireless work happening within your chest. Feel that rhythm, that steady, unwavering pulse, and remember the incredible complexity, the ancient wisdom, and the profound beauty contained within it. It is a living clock, yes, but also an orchestra leader, guiding the symphony of your existence. It is a symbol of life, resilience, and the extraordinary miracle of being. Thank you for joining me on this journey, for your curiosity, and for your willingness to look inward with such profound attention. May your understanding of the heart continue to inspire wonder, fostering a deeper connection to the remarkable life you lead. The fundamental science may be concluded, but the wonder, the appreciation, the profound mystery of the heart truly has just begun. Welcome back, dear friends, to the quiet space we've cultivated together here in the Dreamy Academy. We've journeyed far, haven't we? From the silent darkness of primordial seas, tracing the first tentative pulse of life, through the intricate dance of cellular mechanics, the vast rivers of our circulatory system, the subtle symphony of regulation, and even into the moments when that harmony falters, and the ingenious ways we strive to restore it. Chapter 7, you might recall, offered us a moment of pause, a grand conclusion to the scientific narrative, allowing us to absorb the sheer, astonishing miracle of the heart as a biological entity. We spoke of gratitude, of awe, of the profound appreciation for this tireless engine within us. But now, as we stand at this threshold, I invite you to consider a new horizon, a deeper layer of understanding that perhaps transcends the purely physiological. For the heart, you see, is more than just a pump. It is more than a collection of specialized cells, more than an evolutionary triumph, more than a patient awaiting intervention. It is, and always has been, something far more resonant, far more central to our very sense of being. What echoes does the heart send through the corridors of human experience, beyond the rhythmic thrum we feel beneath our ribs? We speak of matters of the heart, of a heavy heart, a broken heart, a generous heart. We say someone has heart when they display courage, or no heart when they lack compassion. Love, grief, joy, sorrow, these deepest human emotions are universally attributed not to the brain, the seat of reason, but to this pulsing organ in our chest. Why is this so? Why has the heart, across cultures and millennia, become the undisputed symbol of our core essence, our spirit, our true self? Perhaps it is precisely because of its undeniable, unwavering presence. From the first flutter in the womb to the final beat, it is the constant, the anchor, the living clock that marks our time. Before we understood neurons and synapses, before we mapped the brain's complex terrain, ancient peoples felt that steady rhythm, that undeniable connection between their vital force and this internal drum. They saw its cessation as the ultimate end, and its vibrant throb as the very definition of life. Consider the language itself. We learn by heart, we take things to heart, we pour our heart out. These aren't mere poetic flourishes, they're reflections of an intuitive, deeply ingrained understanding that the heart is where truth resides, where our most authentic self is revealed. It is the repository of our deepest feelings, our truest intentions. It is the silent witness to our joys and our sorrows, holding the imprint of every experience. And this symbolic power, this profound cultural resonance, is not entirely disconnected from the science we've explored. Think of the heart's incredible resilience, its capacity to adapt, to heal, to continue its work despite immense challenges. Is it any wonder we imbue it with strength and courage? Think of its central role, pushing life-giving blood to every cell, connecting every part of our being. Is it any wonder we see it as the source of our connection to others, the fount of empathy and love? The very biology of the heart, its tireless dedication, its absolute centrality to our survival, has sculpted our metaphors, shaped our myths, and defined our understanding of what it means to be human. Now, let us venture a little further into the fascinating and increasingly understood territory where the biological heart and the emotional heart undeniably converge. We have spoken of the autonomic nervous system, the sympathetic accelerator, the parasympathetic brake, and how it meticulously regulates heart rate and contractility. But what triggers these responses? Often it is our internal landscape. Stress, anxiety, chronic worry, profound grief, these are not abstract concepts floating in the ether. They are physiological events, translated by our nervous system into cascades of hormones like adrenaline and cortisol, which directly impact the heart. Imagine a sudden fright. Your heart races, your blood pressure surges. This is the sympathetic nervous system responding to a perceived threat. In short bursts, this fight or flight response is vital for survival. But what happens when that perceived threat becomes chronic? When the stress of modern life, the weight of responsibilities, the ache of loneliness, or the grip of unresolved trauma becomes a constant companion. The heart, designed for acute bursts of effort and periods of rest, can find itself perpetually on high alert. This sustained activation can contribute to hypertension, to inflammation, to the very plaque formation we discussed in the context of atherosclerosis. Conversely, think of the calming effect of deep breathing, of meditation, of genuine connection and laughter. These experiences activate the parasympathetic nervous system, lowering heart rate, easing blood pressure, promoting a state of rest and digest. The vagus nerve, that magnificent conduit of calm, plays a central role here, reminding the heart to slow its pace to find its equilibrium. This is the profound, undeniable truth of the mind-heart connection, the psychosomatic reality that medicine is increasingly embracing. Our emotional well-being is not a separate entity from our physical health. It is intricately woven into the very fabric of our physiology, with the heart often bearing the brunt of our internal struggles, or conversely, thriving in the embrace of peace and joy. To care for the heart, then, is not merely to manage cholesterol or blood pressure, it is also to cultivate inner tranquility, to process emotions, to build supportive relationships, to find meaning and purpose. This brings us to a new kind of intervention, one that complements the pharmaceuticals and surgical marvels we discussed. It is the intervention of mindfulness, of conscious connection. I invite you now for a moment to close your eyes if you wish, and simply place a hand over your heart. Feel its steady rhythm. It is always there, a constant companion, a testament to your life force. Can you listen to it, not just with your ears, but with an inner awareness? What does it tell you? Cultivating a mindful relationship with your heart means acknowledging its vulnerability, yes, but also honoring its incredible strength. It means recognizing the subtle cues it sends you, the tightness in your chest during stress, the flutter of excitement, the quiet ache of sadness. It means learning to respond to these cues not with fear, but with compassionate curiosity. This is not a call to replace medical science, but to enrich it. The future of heart health, as I envision it, lies in this profound integration. It is a future where personalized medicine doesn't just look at our genes, but also at our life stories, our emotional landscape, our societal connections. It is a future where prevention extends beyond diet and exercise to include stress reduction techniques, emotional literacy, and the cultivation of purpose. It is a future where the heart is understood not just as a mechanical pump, but as a dynamic, responsive organ intimately connected to our consciousness, our spirit, our very sense of self. Imagine a world where children are taught not only about the chambers and valves of the heart, but also about the power of empathy, the impact of kindness, and the importance of managing their emotional world for the sake of their physical well-being. Imagine healthcare systems that prescribe not only medication, but also mindfulness practices, social engagement, and nature therapy. We are already seeing the nascent stages of this holistic approach, as research increasingly validates the profound impact of these seemingly soft interventions on hard biological outcomes. The journey we have undertaken together in the Dreamy Academy has been one of scientific discovery, of peeling back layers to reveal the astonishing complexity and elegance of the human heart. But as we approach the end of our shared exploration, I hope we carry with us something more than just facts and figures. I hope we carry a renewed sense of wonder, a deeper reverence for this miraculous organ, and a commitment to nurturing it in all its dimensions, biological, emotional, and spiritual. For the heart, in its silent, tireless work, reminds us of the interconnectedness of all things. It is a microcosm of the universe within us, echoing the rhythms of life, the dance of creation, the constant flow of energy. It is a testament to evolution's genius, a beacon of resilience and the symbolic core of our humanity. So let us conclude not with the definitive end, but with an open invitation. The science of the heart continues to evolve. Our understanding deepens with each passing day, but the invitation to listen to your own heart, to honor its wisdom, to care for it with both scientific rigor and profound compassion, that invitation remains, always. May you carry this appreciation with you, allowing it to inform your choices, enrich your life, and deepen your connection to the miraculous pulse of existence. Thank you for joining me on this extraordinary journey. May your heart beat strong, and may its echo resonate with peace and purpose. We have journeyed deep, haven't we? Through the silent, intricate mechanics of a tireless pump tracing its ancient origins from a simple pulsating tube in the primordial ocean to the sophisticated, four-chambered marvel beating within each of us. We have peered into the microscopic dance of ions and proteins, witnessed the elegant ballet of excitation-contraction coupling, and mapped the vast branching rivers of the circulatory system. We've understood the silent conductors, the delicate symphony of nerves and hormones that orchestrate its every beat, and confronted the vulnerabilities, the shadows of disease that can dim its light. We have even explored the diagnostic tools and the profound interventions that modern medicine offers to mend and sustain this vital organ. Now, as our exploration deepens, we gently turn our gaze beyond the purely physiological, beyond the elegant machinery, to understand the heart in its most profound and expansive dimension. For the heart, you see, is not merely a pump. It is a symbol, a resonant chamber of our deepest humanity, a bridge between the physical and the intangible. Close your eyes if you wish and simply listen to the quiet rhythm of your own heart for a moment. Feel its steady presence. This is the same rhythm that has pulsed through every ancestor, every story, every triumph, and every sorrow that brought you to this very breath. This is why across all cultures, all languages, all epochs, the heart has been understood as the very core of our being. It is the seat of courage, the source of our deepest emotions, the wellspring of our capacity for connection, for love, for compassion. Think of the language we use, how it betrays this profound understanding. We speak of a heartfelt apology, a broken heart in grief, a lion-hearted individual facing adversity, or someone with a generous heart sharing their spirit. We refer to learning something by heart, signifying a truth so deeply absorbed it becomes part of us. We talk about following our heart's desire, trusting that inner compass that guides our deepest aspirations. This isn't just poetic flourish. It is an echo of an ancient wisdom, a recognition that the physical heart and our emotional spiritual center are inextricably linked. For centuries, science often separated these realms, viewing the heart as a biological machine distinct from the mind's ethereal thoughts and feelings. But now, with ever-growing clarity, we understand that this separation is an illusion. The mind and the heart are not just connected, they are in a constant, dynamic, intimate conversation, a silent dialogue that shapes our health and our very experience of life. Consider the profound impact of chronic stress. In our fast-paced, often demanding world, stress has become an almost constant companion for many. What happens when our minds perceive threat, real or imagined, over extended periods? Our sympathetic nervous system, that ancient fight-or-flight response we discussed, is continually activated. It's a primal alarm system designed for short bursts of intense action, to escape a predator, to forage for food. But when it remains engaged day after day, week after week, its effects become corrosive. The heart, our responsive orchestra leader, accelerates its pace. Blood pressure rises, not just momentarily, but persistently. Stress hormones like cortisol and adrenaline flood our system, intending to prepare us for battle, but instead they begin to inflame our arteries, making them stiffer, more vulnerable to the insidious buildup of plaque we know as atherosclerosis. This continuous state of alert demands more from the heart, working it harder, diminishing its reserves, and contributing to a landscape ripe for hypertension, coronary artery disease, and even arrhythmias. It's a relentless wear and tear, born not from external physical threat, but often from internal emotional states: anxiety, fear, unresolved grief, chronic anger. But the conversation flows both ways, beautifully and powerfully. Just as negative emotional states can burden the heart, positive emotional well-being and mindful practices can profoundly foster its resilience. When we cultivate a sense of calm, when we engage in practices that soothe the nervous system, we activate the parasympathetic branch, the rest and digest system. This is where healing begins, where regeneration flourishes. Imagine a gentle hand on the reins, guiding the heart back to a more harmonious pace. Mindfulness, for instance, isn't just a trend, it's a profound practice of bringing our attention to the present moment, observing our thoughts and feelings without judgment. When we do this, we begin to interrupt the endless loops of worry and rumination that can keep our stress responses elevated. Deep diaphragmatic breathing, a cornerstone of many mindfulness practices, directly stimulates the vagus nerve, a powerful conduit of the parasympathetic system. This signal tells the heart to slow, to relax, to find its natural unhurried rhythm. Gratitude, too, plays a remarkable role. When we actively cultivate appreciation, even for the smallest things, we shift our perspective, reducing feelings of threat and increasing feelings of connection and well-being. This emotional shift has measurable physiological effects, promoting a healthier heart rate variability, a marker of a resilient, adaptable cardiovascular system. Love, connection, compassion, these are not just abstract concepts, they are biological imperatives for heart health. Social isolation, conversely, has been identified as a significant risk factor for heart disease, comparable to smoking or obesity. We are, at our core, social beings, and our hearts thrive in connection. So as we contemplate the future of heart health, we realize it must be a holistic future. It must integrate the meticulous scientific rigor we have explored with a deep understanding of our emotional landscape, our mental well-being, and our social connections. It calls for a vision where medical interventions, while critically important, are part of a larger tapestry of care that includes emotional literacy, stress reduction techniques, and the cultivation of meaningful relationships. This means moving beyond simply treating symptoms or repairing damage, and instead empowering individuals to become active participants in nurturing their own hearts, in all their dimensions. It means recognizing that the heart is not merely a patient to be fixed, but a sacred center to be honored and protected. It means understanding that the choices we make daily, not just what we eat or how much we move, but also how we respond to stress, how we connect with others, how we cultivate inner peace, all contribute to the vitality of this wondrous organ. Imagine a future where preventive cardiology includes prescriptions for mindfulness practices, where emotional support is seamlessly integrated into cardiac rehabilitation, where communities are designed to foster connection rather than isolation. This is not a fanciful dream. It is the logical evolution of our understanding, a return to a more integrated view of human health. The heart, our ancient drum, our internal river system, our living clock, continues its tireless work, a testament to billions of years of evolution. It asks of us not just a scientific understanding of its mechanisms, but a profound reverence for its role in our lives, a commitment to nurturing its resilience, and an openness to its capacity for connection and love. It is, after all, the very essence of what makes us alive, what allows us to feel, to strive, to connect, to be. To care for it truly is to care for the very core of who we are. And so we arrive at this precipice, this wondrous threshold where the scientific rigor of our journey through the heart's intricate machinery meets the boundless landscape of its symbolic and spiritual resonance. We have traversed the silent darkness of primordial oceans, witnessed the genesis of a single pulsating tube, and marvelled at the exquisite precision of a four-chambered pump, a living clock beating out the rhythm of our very existence. We have delved into the microscopic ballet of cardiomyocytes, the electrical symphony of action potentials, and the intricate dance of sliding filaments, all orchestrated by mitochondria, those tiny powerhouses of life. We have charted the ancient rivers of the circulatory system, navigated the complex currents of the autonomic nervous system, and understood the delicate balance maintained by a cascade of hormones and vigilant sensors. We have confronted the heart's vulnerabilities, learned to diagnose its ailments, and explored the remarkable interventions that modern medicine offers. Yet as we drew closer to our present moment, we began to sense a deeper truth, a whisper beneath the steady beat. The heart is more, infinitely more, than a mere biological engine. It is a nexus, a sacred, interconnected center, not just of our physical being, but of our emotional landscape, our courage, our compassion, and our profound capacity for connection. We spoke of the undeniable mind-heart connection, how the relentless pressures of chronic stress can ripple through our physiology, activating sympathetic pathways, flooding our systems with cortisol, and ultimately impacting the very health of this vital organ. And we illuminated the counter-narrative, the profound resilience fostered by practices of mindfulness, gratitude, and authentic social connection, coaxing forth the soothing embrace of the parasympathetic nervous system, bathing the heart in a balm of calm. Now, as we stand here gazing into the heart's deepest chambers, we are invited to consider a future, not just of surviving, but of truly thriving. What does it mean to embrace a holistic vision of heart health, one that integrates scientific rigor with emotional well-being, acknowledging the heart as this sacred, interconnected center of our being? Imagine for a moment the heart not merely as a pump, but as a sophisticated antenna constantly receiving and transmitting information. We know its electrical activity generates an electromagnetic field detectable inches, even feet, away from the body. What if this field, this subtle energy signature, is not just an isolated phenomenon, but a conduit? A way in which our inner state, our joy, our sorrow, our fear, our love, subtly interacts with the world around us, and indeed with the hearts of others. Is it so far-fetched to consider in the quiet of our reflections that the heart in its profound wisdom is attuned to frequencies far beyond our current scientific measurement capabilities, a silent participant in an unseen symphony of life? For millennia, ancient wisdom traditions across cultures have intuitively understood this. They have spoken of the heart as the seat of the soul, the core of one's spiritual essence, the wellspring of compassion and courage. They didn't have ECGs or echocardiograms, yet they recognized its central role in our emotional and spiritual vitality. Is it not remarkable how modern science, through its rigorous exploration of the mind-heart connection, is now beginning to echo these ancient insights? We are discovering that practices like meditation and conscious breathing, long championed by these traditions, directly influence heart rate variability, a key indicator of cardiovascular health and resilience. We are learning that acts of selfless service and compassion not only benefit the recipient, but also release oxytocin in the giver, a hormone known to have cardioprotective effects. This integrated view invites us to expand our definition of heart health far beyond the absence of disease. It challenges us to consider what it means to cultivate a heart that is not just physically robust, but emotionally vibrant, spiritually resonant, and deeply connected. How do we nurture a heart that beats not just with biological efficiency, but with purpose, with empathy, with a profound sense of belonging? It begins, perhaps, with an act of radical self-compassion. For too long we have treated our bodies, and particularly our hearts, as machines to be maintained, repaired, or even pushed to their limits. But what if we approached our hearts with the same tenderness, the same reverence that we would offer to a beloved friend? What if we listened to its rhythms, not just as a medical indicator, but as a profound communication from our inner self? When we feel stress, when our hearts race with anxiety or clench with fear, what if we paused, placed a hand over our chest, and offered a moment of gentle acknowledgement rather than judgment or suppression? This simple act, this moment of mindful presence, can begin to shift the internal landscape, signaling safety to the nervous system and inviting the heart to soften. This cultivation extends outward too, into the intricate web of our relationships. We are, by our very nature, social beings. Our hearts thrive in connection, in the warmth of shared laughter, the solace of a listening ear, the strength found in mutual support. Loneliness, conversely, has been identified as a significant risk factor for cardiovascular disease, sometimes even more impactful than traditional physiological metrics. Why? Because isolation triggers a chronic stress response, keeping the sympathetic nervous system on high alert, flooding the body with inflammatory markers, and slowly, insidiously eroding the heart's resilience. So nurturing our relationships, actively investing in our communities, reaching out to others, these are not just pleasant social pastimes, they are acts of profound heart care. They are, in essence, medicine. Consider also the power of gratitude, a practice we've touched upon. When we consciously shift our focus to appreciation, even for the smallest blessings, we are not just changing our mood, we are literally changing our heart. Research shows that gratitude can improve heart rate variability, reduce blood pressure, and foster a more coherent heart rhythm. It's as if the heart, when bathed in gratitude, begins to sing a more harmonious tune, a melody of well-being that resonates throughout the entire system. And what of purpose? What of that deep internal compass that guides us towards meaning and contribution? A life lived without purpose can feel adrift, a rudderless ship vulnerable to every storm. But a heart beating with purpose, whether it's through creative expression, contributing to a cause, or simply caring for loved ones, is a heart infused with vitality. It provides a sense of direction, a reason to engage with life, and a buffer against the inevitable challenges we face. It fuels a quiet resilience that allows the heart to navigate stress with greater ease. So where does this leave the future of cardiology? It suggests a profound evolution, doesn't it? A shift from a purely mechanistic approach to one that is truly holistic, integrative, and deeply human. The future cardiologist, while still a master of physiology and intervention, may also be a guide in cultivating well-being, an advocate for lifestyle as medicine, and a champion for emotional and spiritual health. We envision a future where patient care extends beyond prescriptions and procedures to include recommendations for mindfulness practices, social engagement, purpose-driven activities, and even connection with nature, recognizing the profound healing power of the natural world on our inner landscape. Imagine a cardiology clinic where stress reduction workshops are as routine as blood pressure checks, where nutritional counseling is integrated with discussions on emotional eating patterns, where patients are encouraged to explore their sense of purpose and connection as vital components of their treatment plan. This isn't just wishful thinking, it's the logical progression of our understanding of the heart's true nature. It's an acknowledgement that the heart does not exist in isolation, but as an intricate part of a larger system, the individual, the family, the community, and indeed the entire planet. This integrated vision is not about replacing advanced medical science. It is about enriching it, making it more comprehensive, more effective, and ultimately more compassionate. It's about empowering each of us to become active participants in our own heart health, to listen to the wisdom of our bodies, and to cultivate an inner environment where our hearts can flourish. For I believe deeply that the heart is a testament to the evolutionary brilliance of life itself. It is a miracle of engineering, yes, but also a profound symbol of our capacity for love, for resilience, for connection. It is the quiet, powerful drum that beats the rhythm of our unique journey, a living reminder of our shared humanity. So, as we conclude this chapter of our exploration, I invite you to carry this understanding with you. Feel the beat of your own heart, a steady, unwavering presence within you. Recognize its profound intelligence, its tireless dedication, its capacity to connect you to every breath you take, every emotion you feel, every person you encounter. This journey into the heart has been, I hope, more than just a lecture. It has been an invitation to wonder, to learn, to reflect, and ultimately to honour this magnificent organ, not just as a biological marvel, but as the sacred, interconnected centre of your extraordinary life. Thank you for embarking on this journey with me. May your heart beat strong, full and free,